Hello student, in this video I am going to discuss about sequence diagram. That is also very important in case of software design or system design or analysis, or while we are trying to develop a information system, we need to go through this type of diagram for better understanding. We have also understand use case diagram. Actually that sequence diagram is related with the use case diagram. Here you can see a use case is a collection of interaction between external actors and a system that we have discussed in the use case diagram video. In UML, Unified Modeling Language, a use case is the specification of a sequence of actions including variants that a system or entity can perform interacting with the actors of the system. So in the use case diagram we try to specify the sequence of actions including variants that the system can perform interacting with the actors of the system. Typically its use case includes a primary scenario. Yes, we can know that scenario is included in the use case diagram, or main course of events, and 0 or more secondary scenarios that are alternative courses of events to the primary scenario. In RUP, rational unified processes, these means rational unified processes means those processes which are included in your system software or system design or software design. User requirements are captured. So to capture the user requirements, we use the use cases that are refined into scenarios. Then a scenario is one part or flow through a use case that describes sequence of events that occurs during one particular execution of a system. So here in case of sequence diagram we will follow this line where a scenario is one path or flow through a use case that describes a sequence of events. It describes a sequence of events that occurs during one particular execution of a system. So what is UML sequence diagrams? It describes the flow of messages, events, actions between objects, and it shows concurrent processes and activations. So time sequences that are not easily depicted in other diagrams. So time sequences that are not easily depicted in the other diagrams, typically used during analysis and design to document and understand logical flow of your system. So this is the need, and this is why we use sequence diagram. Whenever we want to show the flow of the messages which are not shown in the US diagrams, and the events and actions between the objects. So concurrent processes, sometimes we use concurrent processes in case of activity diagram, but also here also we can show the concurrent processes and activation. In the activity diagram also we use concurrent processes, but there also no messages has been included. Means what type of messages or what type of actions are going on between the objects are not showing in the use case, also in the activity diagram also. So here we can show that. So time sequence, we use time here. So time sequence that are not easily depicted in other diagrams, typically used during analysis and design phase to document and understand the logical flow of your system. And the very important part is that we directly emphasize on the time ordering. So here in the sequence diagram some key parts are like participant, messages, the axis in a sequence diagram, axis in the sequence diagram, horizontal or vertical. So participants are objects or entity that acts in the diagram. So diagram starts with an unattached found message arrow. Unattached found message arrow. We will see through an example. Message is the communication between participant objects, and a horizontal axis which objects participant is acting at that time, and vertical is used to show the time with a down arrow or forward in time. Here one example, here you can see suppose you want to make a phone call, then that caller will picks up the phone. That are objects. Caller is an object, or you can see entity. Phone is an entity and the recipient is an entity. So caller try to do this event, picks up the phone, then on that side of caller will dial the tone or dial the number, then again it will confirm it dialing the phone, then it will ring and the recipient will receive the ring. In the same time or in between these two events, one ring notification might goes to the caller, and again after the ring notification, that picks up recipient object picks up the phone, and both side or that recipient might say hello, and that hello will go to the caller. So here you can see this is a sequence of events, and here you can see how these things are ordered in timely. Means this event happens after this event happens after this event happens after this event, but between this event another event might occur between two objects. So that is why we use sequence diagram. So this is the things are showing here sequentially, what happens after what, that is what it is used. Here you can see squares with object type optionally preceded by name. Here this is the object that might be anonymous, means you can put the name of the object, Smith, and type of the object, and also you can put the object name itself by without putting the name of the object. You can put the type of the object. So these are active object of unknown class. You can put the name also, name of one object, but you might not give the type of the object also, so it will create a unknown class. So basically this type of events is associated with object oriented languages. Write object's name if it clarifies the diagram. Object's lifeline represented by dash vertical line. So this is dash vertical line is the lifeline, or this is timeline of this object. So here name of the syntax, object name and class name. So class name is the patient, or you can say object type, and object name we can give the object name and class name itself, then and again we might omit the object name or we might omit the class name, then it will become like anonymous object or unknown class. And here you can see these are this line dashed line is the object lifeline. And again in case of messages, or you can say method call indicates by arrow to other objects. This is the arrow to other objects from one object to another objects, and this is the message name. Whatever message you are passing to the object, that message name will be here, and you need to give the arguments, what type of inputs or arguments you are giving in the message. Write a message name and arguments above the arrow. And other things to be noted here this is incoming, okay, flat flow of control, and this is that dashed arrow line is for return, dashed arrow black indicates return. This is again procedure call, or same type of procedure call or method calls. This is if the arrowhead is only one part, this is asynchronous. Different arrowheads for normal or concurrent calls. So this type of call can be concurrent, means parallel call can be given like this, or normal arrowheads can be also be given. This arrowhead is like triangular arrowhead, and black triangular arrowhead, that is for procedure call. So here you can see creation, arrow with new written above. This is new written above. Here you can see it is for creation. Notice that an object created after the start of the scenario appears lower than the others. So here these objects created a new object. So then this object will appear near lower to the original objects. That is how we can show the time order, and that is why this is new creation. When you create a new object, that object will appear lower than the base object or base class. And again you can use deletion and X at bottom of that object lifeline. So we know that the dash line or the line, this vertical line is the lifeline of that object. So if we put X in the end of the line, we can say that that object has been deleted. So Java does not explicitly delete objects, they fall out of scope and are garbage collected. So we can know from the Java programming that, or you can use C++ also, where objects might not be explicitly deleted, they might be out of scope and they are collected in the garbage. So this is self deletion or deletion from other objects, that can be also done. Deletion by itself also can be done, or this deletion is by these objects. So this will not appear, this dash line will not appear after this, but this dash line appears because this has not been deleted, and this is creation of new object. So we'll go for more important things here. Activation, thick box over object lifeline drawn when object method is on the stack, means when the controller object, here you can see controller object or controller class is on working mode, or you can say objects method, the working method is on the stack, means is on line or is on live or is in working condition, then it will put that activation. This is thick box over the object lifeline or dashed line. Either that object is running its code or it is on the stack waiting for another object's method to finish. So here we can see that this object is running the code, or it might wait for another object's messages or objects finish to work. So how much you give this thick line, it means that much of amount of time or that much time it will run, that object will run. And you can also give nested activation to indicate recursion program. Here you can see above the first thick box you can put another thick box to show that these two objects, these two event or these two method are nested, means one is happening inside another, and if this completed, then only this can be completed. If this cannot be completed without completing this, because these are recursively nested. So we can use this nesting also. And also this is the activation, we can directly create the activation, and this is the end of that object by ending that thick box over that dash line. Frame, you can use frame box around part of a diagram to indicate if or loop. Here you can see this is a frame, you can use and you can mention the loop, or you can mention the alt operator like that to specify the loop. For if condition you can choose opt condition, optional condition, if else alt condition. If there is if else condition you can put alt, but if you only give if condition you can give opt. Loop, for loop you can give loop condition here. So this part will work in a loop, this looping, and this part, this frame will work in if else condition, and this part will work in if condition opt. In that way you can put a box around a part of the diagram, to mention or to specify the looping or alternate if else loop, if else conditions, or single if conditions. This is the frame you can put. Here you can see this is the guard. Guard is used, guard means conditions. So this part will happen for if and this part will happen for else. And this in case of if only or opt only, we can go for directly if condition. So no need to put any guard conditions, or just need to it needs to confirm this condition. You need to put the conditions here, needs confirmation. Here also you can see value greater than $10,000, or here you can see for each line item. So these are like conditions or guard conditions. But in case of if else, you can put a dash line to separate the conditions, separated by horizontal dash line. If else is separated by horizontal dash lines. Sequence diagram from use case scenario. From the use case scenario, we can draw the sequence diagram. So here, this is the customer, this is the search page, this is the search result page, catalog, and search results. Basic course: the customer specifies an author on the search page and then presses the search button. So on search, so customer presses the search button, so it goes to the searching page. So on search, it will go to this page. The system validates the customer search criteria. So system validates the customer search criteria. It is coming back, validate the search criteria to itself. So that validation is coming to itself, and then the system searches the catalog for books associated with the specified author. Then it will go for the catalog to find the book which has been searched by the customer, searched by author, and the searching is done using the name of the author. When the search is complete, in the catalog, the system displays the search result. It will display, or it will create this displaying option. Okay, displays the search result on the search result page. Alternate course is that. Alternate course means this is alternate course. If the customer did not enter the name of the author before pressing the search button, the system displays an error message here. If author does not put any author name in while putting that search button, if the customer does not put any author name, then it will display an error message. That is an alternate course. So that is an alternate course. The system displays an error message to that effect and prompts to the customer to re-enter an author name. So you can understand, and you can draw the use case diagram also. So why not just code it? So sequence diagrams can be somewhat close to the code level. So why not just code up that algorithm rather than drawing it as a sequence diagram? A good sequence diagram is still a bit above the level of real code. Not all code is drawn on diagram. Sequence diagram are language agnostic, can be implemented in many different languages. Non-coders can do sequence diagrams. Easier to do sequence diagram as a team. Can see many objects classes at the time on the same page. Visual bandwidth. So everything you can see visually, or any non-coder person can draw this one, or you can, a team as a whole can work on the same scenario. So that is why we can go for directly sequence diagram before doing the code. And always a good sequence diagram is still a bit above level, means that is not exact the code. And we can draw sequence diagrams which are language agnostic, means can be implemented in different languages. So let's do a sequence diagram for the following poker casual use case. Suppose this is another poker game. So we need to create the game round. The scenario begins when the player chooses to start a new round in the UI user interface. The UI asks whether any new player want to join the rounds. If so, the new players are added using the user interface. All players' hands are emptied in the deck, which is then shuffled. The player left of the dealer supplies an ante bet of the proper amount. Next, each player is dealt a hand of 2 cards from a deck in a round robin fashion, and 1 card to each player, then the second card. If the player left of the dealer does not have enough money to ante, he is removed from the game and the next player supplies the ante. If the players also cannot afford the ante, this cycle continues until such a player is found or all players are removed. we need to design this sequence diagram. So here you can see this is the sequence diagram. This is the user interface. First, starting from this one, it will search for new player, that's this nested. Then it will add the player in the table. It will found new players, it will add the players, it will go for the table 1, it will create new object, new player, that is also you can see here, new player is the object name, and then this class type, and again that UI will create a new game, and again here you can see this is nested for each player. This is a loop. You can do frame also, you can put like this also. Empty hand, for empty hand it will go for this player, it will go for add cards in the deck. Again from this step, this is nested, this will go in a recursive way for 2 cards and for every player. That is why for each player this will go for in a recursion, in a loop. And then shuffle, it will shuffle the deck, while left player cannot provide the money or ante and players are remaining, till then it will go and remove player, leftmost player, it will go. So this is double nesting. If players are remaining, if there are some players who are remaining and who can play, then you can go for this one. If that does not, it will not require if there is no player left who have money to play, then it will pay the money, it will provide the money, and it will provide the bet, and for each player it will draw card, it will get card from the deck, a card like that, and else this part go to end game scenario. So you can see you can correlate this text in this diagram. So consider the possible poker use case, betting round. The scenario begins after start new round. Case has been completed. The UI asks the first player for a bet. The first player for a bet. Start new round. First player for a bet. The UI, that player chooses to either be bet a given amount or check. The next player is asked what to do. If the prior player plays the bet, the next player must either watch match it or match it plus add additional bet, raise, or choose not to match and exit the round, fold. This continues around the table until an entire pass is made, which all players have either matched all other players' bets or folded. If the next player does not have enough money to match the current bet, the players is allowed to bet all of their money, but they can then win only up to the amount they bet. The rest is a side pot among the more wealthy players remaining the round. So this also a scenario that you can add. So why is it hard to diagram this case as a sequence diagram? We'll try to understand here. This is the way, get current player, set bet. In that way you can go. Current player, set bet amount or double. Current player, is legal bet amount. If it is legal, then it will provide legal. Then it will alt legal. Alt means if legal, then it will go for card. Then else it will remain here. Some part are missing in this diagram, not visible enough, but try to understand from this one also. I have given just this example for understanding, and you might not understand properly. If you don't understand properly, then again ask me. I'll try to resolve it over Google Meet. This is important to understand, because anywhere in future, if you want to draw some sequence diagram having such complexity, you need to understand this type of diagram right now. And if you have any confusion, or you can if you want to share anything else regarding this, you can we can meet over Google Meet. So try to go through the context and the text, and mainly try to understand the rules and regulations to draw the sequence diagram and why it is important, and it will give us more very crisp knowledge about the sequence of the events and message passing among the objects. So that's it in this video. Thank you.